Here we want to find the horizontal asymptotes for f of x equals 3x plus 1 over the quantity x plus the square root of 4x squared plus 5. So first let's talk a little bit about what horizontal asymptotes are. Horizontal asymptotes are lines that a function approaches as x goes to infinity and as x goes to negative infinity. And you can have 0, 1, or 2 horizontal asymptotes. So let's quickly take a look at some graphical examples of what those might look like before we dive into this particular example. Okay, so here's a rough example of a function with one horizontal asymptote. Some things to note here. Note that the horizontal asymptote can be crossed, right? It's not like a vertical asymptote. Vertical asymptotes are never crossed. Horizontal asymptotes are. Really, horizontal asymptotes are just talking about end behavior out here. So here this has a horizontal asymptote at about 2, y equals 2. Y equals 2, right? So you want to represent your horizontal asymptotes usually as a line like that, though people will understand what you mean if you just say a horizontal asymptote at 2. Okay, other functions might have 2 horizontal asymptotes to denote what happens as the function approaches the two different infinities. So as x goes to positive infinity and as x goes to negative infinity. Note that this function here has two different limits at infinity, so to speak. So we'd say that it has two different horizontal asymptotes. Y equals 2 and y equals negative 1. Okay, the last thing to address here is a function with no horizontal asymptotes. And just picture any polynomial. All polynomials have no horizontal asymptotes. Right, there's a simple polynomial. We'll call it p of x. And note that this thing just keeps going up. I mean, you don't know for certain the way I've drawn it, but I'm just saying it keeps going, and this keeps going down like that, we'll say. Right? It never approaches any value other than infinity or negative infinity. So in this case, you could start talking about slant asymptotes, which we will say for a different video. So to find the horizontal asymptotes, we need to take the limit as x goes to infinity of the function, and then the limit as x goes to negative infinity of the function. So remember our key to these kinds of limits? Divide everything by the largest power in the denominator. So here we have, in the denominator, we have x and we have the square root of x squared. I'm going to focus on the square root of x squared, and you should too, because that's going to matter. That square root business is going to matter when we take the limit as x goes to negative infinity. And again, this is one of the more challenging aspects in all of, at least the first part of Calculus 1, is this dealing with this x goes to negative infinity. Okay, so I'll multiply both the top and bottom by the square root of x squared there, and then the square root of x squared down here. Now, since we're going to positive infinity in this case, we can happily replace square root of x squared. Note that technically that's absolute value of x, but we can simply write that as x in this case because we're going to positive infinity. When we go to negative infinity, we'll have to write it as negative x. We'll talk about that in a sec. So up top, I'm just going to write this as 1 over x instead. Down below, for where we have x here, I'll write it as x. And then where we have the square root, I'll just combine these inside the same radical. Okay, so this is getting complicated, so let's rewrite things a little bit. So now we have the limit as x goes to infinity. I'm going to distribute this 1 over x up in the top here. So we have 3 plus 1 over x up top. Down below, we now have, well, x divided by x is 1 plus the square root of, now I'm bringing this x squared inside the square root. So we have 4 plus 5 over x squared. And now we evaluate our limit, which means anything with the constant up top and x below goes to 0. So 1 over x goes to 0, 5 over x squared goes to 0. That takes care of our limit and leaves us with 3 over 1 plus square root of 4. Well, 3 over 1 plus 2 is 3 over 3, which is 1. Okay, so then we'd say our horizontal asymptote is y equals 1. Now in this example, we need to give it a little bit more thought as x goes to negative infinity here. So let's see here. We start out the same. We look for the largest power of x in the denominator, and we take the square root version if there's kind of 2 with the same power. So here we'll multiply by 1 over square root of x squared. up top, and again 1 over square root of x squared down below. But now we have the same issue. Square root of x squared is actually absolute value of x. And in calculus, we use the more rigorous definition of absolute value of x. Absolute value of x equals x as long as x is greater than or equal to 0, but we have to replace it with negative x when x is less than 0. And as we go to negative infinity, x is going to be less than 0. So the takeaway is that if we're evaluating the limit as x goes to negative infinity of f of x, we replace absolute value of x with negative x. Okay, so what does that do for us here? So here I'm going to replace x squared up top with negative x for that same reasoning. In the denominator, I'm going to distribute this square root of x squared through to these two different terms. And when we're just dividing x, I'm going to write it as the absolute value of x, which will become negative x because we're taking negative infinity. And then when we're under the square root, I'm just going to leave it as a square root and combine inside that square root. Okay, just so distributing this through, erase that. That gives us x over negative x here, and then over square root of x squared under the square root here. So you can see why I said this is one of the more challenging aspects of the first part of the course. It's very subtle, and if you make one little mistake, you get the wrong limit. Okay, so it's getting a little busy here. Let's rewrite this limit. So we have the limit as x goes to negative infinity, okay, of, well, now we have negative 3 minus 1 over x. That's distributing this term here, 1 over negative x through to the top there, over negative 1 plus the square root of 4 plus 5 over x squared. Okay, now we can evaluate our limit. Anything with a constant up top and x in the denominator goes to 0. So 1 over x goes to 0, 5 over x squared goes to 0, leaving us with negative 3 over negative 1 plus 2, which is negative 3. So we'd say we have a horizontal asymptote of y equals negative 3. Okay, so two different horizontal asymptotes for that graph. Let's conclude by taking a look at this graph in Desmos. Okay, so here's our function in red. Along with the two horizontal asymptotes, the blue dashed lines are the asymptotes. And you can see there that it indeed approaches those two asymptotes as we go off in the different directions of infinity. And I don't know if you can tell or not from this graph, but if you look real closely, it actually goes up above the horizontal asymptote on the right there. And then approaches it down from the top. So this example does cross the asymptote. Maybe we can zoom in. See how it crosses the asymptote and then comes back down and approaches it from the top there. So horizontal asymptotes can be crossed. Vertical asymptotes cannot be crossed.